Hi, welcome to the Introduction to 3D Studio Max presented by 3dtotal.com. My name is Isaac Oster, and in this lesson I'm going to talk about the render to texture workflow. Render to texture is good for a variety of things. You can use it for texture baking, which allows you to set up lights in a scene and then bake a texture out that includes that lighting information. You can also use it to capture high poly detail in the form of a normal map, which you can then apply to a low poly model for use in a real-time engine, such as a game engine or the 3ds Max workspace. So to bring up the render to texture menu, all you got to do is hit the 0 key. And as you can see, it's pretty long, but you don't have to worry about some of this stuff. There are just a few important sections. The output section is where you tell Max where to put the images that it creates. This area right here will be what objects you are baking, so I don't have anything selected, which actually grays out a lot of these options. So I'm just going to select the low poly, and you can see it shows up right there. So what padding does is it actually will bleed the render beyond the UV border by this number of pixels. So why this is relevant is because of a thing called MIP mapping. So I'll just bring an image over real quick. So if you generate your texture at 1024 or 2048 or whatever, and export this into a game engine, what it does automatically is it takes the image and it assigns double the amount of texture space to it. And then it creates a 512 version, well, a 1/4 size version of whatever your original image is, and then a quarter of that, and a quarter of that, and a quarter of that, and so on until you get down to a pixel. And as the object that this texture is applied to gets farther and farther away from the camera, it will automatically drop down to these different texture densities according to the distance. And that's an efficiency thing, so that you don't have to pay for this much texture memory when there's only this much of the object visible on the screen. But what happens is these little boundaries here can become kind of blurry as you go down. So down here in this zone, what'll happen is you'll end up with these seams all over your texture, which can be very distracting, and you want to avoid it. So with the padding, what this will do is it actually, wherever the UV seam happens to be, is it'll take whatever that value is and just push it as far as it can until it runs into the pushed boundary of another UV island. So my general rule of thumb is if it's a 1024 by 1024, you want to make the padding about 10, and if it's a 512, you can make it 5, and if it's 2048, 20 is a lot, but maybe 15. 2 is the default value, and it's usually not enough. So what the projection modifier is for creating normal maps or ambient occlusion, and what that does is it says you should look at this other object, which shows up as the projection target, and look at the surface of that, and then create a map that captures the difference between the low poly surface and the high poly surface. The mapping coordinate section here should be set to channel 1 and use existing channel. What that means is you want to use your UVs. You don't necessarily, like if I set this to a different channel, it's going to throw an automatic unwrap modifier on there, and the UVs will just be kind of whatever Max thinks they should be, which is never ever correct. So always leave this at 1 and always have use existing channel selected, and if you've got sub objects, just make sure this is set to 1 and this is set to use existing channel. This next section here determines what you want to output. So I have a lighting map in there. You can add anything you like here. Diffuse map, shadows map, and normals map are the ones we'll be talking about after the lighting map. You can determine what the output resolution will be, 1024, 2048, or you can enter in something specific here. And that's pretty much all you need to worry about. You just hit render and it'll generate an image for you. So let's make a lighting map first. What a lighting map is going to do is capture the lighting on an object in the form of a texture. So in order to have this work properly, all of the faces need to have unique UV space. So I will we'll just go ahead and throw an unwrap UVW modifier onto the object. And by default, cubes will have their UVs, each face will go from 0 to 1. So we'll just do a flatten. Now each face has its own unique space. And I will add some lights. And I'll just make some different colors for them so we can see the influence of these lights. Select the object, hit 0 to bring up the RTT menu. And I have my lighting map assigned. I'll make it a 1024. And I will be outputting these to the 3D Total folder. Hit render. And there you go. So each one of these represents the lighting that each face was receiving. So now what I can do is delete these lights and go grab that render and assign it to the cube. So even though there are no lights in the scene, the cube is still has the appearance of being lit, and it's all just being done in the texture, which saves a lot of processing on the part of the game engine. So the next thing that I'd like to show you is called a shadows map, and the shadows map is going to use a skylight. So I'll just create a skylight and turn on cast shadows, and I've done an automatic UV unwrap on this so that each face has unique space in the texture map, and I've added this plane down here, and what this plane is going to do is actually cast shadows onto the bottom of the cube here, because they're close, because they have proximity, whereas there's not really anything above or to the sides of the top of the shape. So we just need to select the cube, hit 0 to bring up the render to texture menu, and other than a lighting map, which we can delete, we're going to add a shadows map, and we'll set it at 1024. Okay, so I paused the video while this is rendering. So this is the result. Let's go ahead and apply it. We don't need this anymore. And now it'll be low poly shadows map as opposed to lighting map. But it gets plugged into the same place, the diffuse color section. So, this is what it looks like. The underside is very dark, and the interior spaces here are dark, but this top surface here is fairly light. So it looks like it's being lit almost by a cloudy day. And this can form a really nice foundation for an actual texture. You just use this on a multiply layer on top of whatever your texturing is in Photoshop, and you get this the benefit of this ambient lighting. Okay, the next thing I'd like to talk about are normal maps. But before I get into the creation process, I want to kind of break down how they work. So we saw in the last lesson with bump maps how where the bump map is darker, the surface appears to be pushed in, and where the bump map is lighter, it appears to be pulled out. Now, it doesn't actually change the position of the surface, it just changes the way that it lights. So there's a single channel image, a grayscale image, and it goes from 0 at the low end to 255 at the high end, which is an 8-bit range. The 0 is black and 255 is white. So where bitmaps only have, or bump maps only have one channel, or 3 identical channels, a normal map has 3 unique channels. So there is the blue channel, which controls the vertical position of the pixel, but there's also a red channel and a green channel, and each one of these has a range from 0 to 255. But rather than being an up and down, it's a direction. So rather than capturing simply the vertical position of a pixel, you can also capture the direction that it's pointing. And using this technique, you can simulate really complicated surfaces. So long as you have the silhouette of the object, it will light as though it's got all kinds of detail on it, from rivets and panel lines if you're doing hard surface work, to cloth and seams if you're doing clothing. So this is what a normal map looks like. This is pretty typical of their general appearance. They tend to be these purples and teals and blues. And again, these are just those vectors. So this being red over here means that on the surface, this area here is actually pointing a specific direction, and this is pointing the opposite direction. This blue value here means there's no change. This is the low poly and the high poly are the same, or in this case, there's actually no geometry here in the UV, so this is just a flat map. So let's look at the channels real quick. So this is the red channel, and where it's brighter, it's going one direction on the surface, and where it's darker, it's going the other direction. And with the green channel, it's going perpendicular, brighter and darker, depending on what the green channel contribution is to the surface. And the blue channel is depth. So you can see the range here is less than with the other ones, but it's still a contribution. So something worth mentioning about normal maps is they're designed to work in a real-time environment only. So if you are needing this kind of functionality for a software render, such as the default scanline or mental ray, you would want to use a different process, either a regular bump map or a displacement map. If your application is for a video game engine or something that will work in the workspace of Max or Maya, then a normal map is the way to go. So you can see here some of this finer detail. And Max is not that great at simulating the way these maps look, but there's another piece of software that I like to use called Marmoset, which I'm going to show you in just a moment. So Marmoset's main function is simulating game shaders, and it's got some pretty nifty lighting bells and whistles as well. So this is what the geometry to that map I just showed you looks like, and as you can see, it's very low detail. There's just the big shapes here. But if I apply that normal map to it, what we can see is all of that detail really comes in looking pretty nice. So there's the strap detail and the pockets and the panels with the rivets, and all of that is happening in the normal map. So the benefit is we get all this detail, but we only have to pay for a few thousand triangles. There's many millions of polygons on the high poly model that generated this map. Okay, so now that I have explained how normal maps work, let me show you how to generate some. So I will, I've got the scene here with two cubes, the low poly cube and the high poly cube, and they need to be in the same exact position. So I'm just going to zero them out here. And they share the same relative pivot position. So I'm going to select the low poly and hit 0 to bring up my render texture menu. And need to come down to the projection mapping section. And I'm going to click Pick. And this will bring up a list of all of the other objects in the scene. In this case, there's only one. And set up a projection modifier on it, as you can see right here. So I've also increased the padding to 10. And I will hop over to the projection modifier in just a moment. But first I want to make sure that I add a normals map to the output section here and set its resolution to 1024 by 1024. So in the projection section, there's a cage, face, and element, and what I need to worry about for now is this cage, which is this blue outline here. And what this is basically it duplicates the low poly geometry and then pushes it out from the surface. And it'll look inside this box at the two pieces of geometry that are selected and create a map that captures the difference between the two. So what you need to make sure is, because at various times the high poly can be further out or the low poly can be further out, everything just needs to be inside the boundaries of the cage. So that is it's pushed out far enough to capture everything. So I'm just going to go ahead and click Render. So what you notice is pretty quickly this doesn't look anything like a normal map. And it's important to mention that when you're rendering, many times what you'll see here is actually just a proximity render, and it's rendering these textures based on where my camera is. So this face is probably one of these, and this face is probably this one, and so on. But this doesn't actually have any relationship with the map that I just generated. So I want to make sure that I don't come up here and try to save it as the normal map. That normal map already exists and was saved sort of behind the scenes by Max. So I can go ahead and close this and bring over the material editor here. I'm going to hit Alt-Q to isolate the low poly cube, and I'm going to go and delete the projection modifier, get out of the way. And I'm going to click on this little plus sign here and go to Configure Viewports and turn off selection brackets. So for some reason, Max has a default value of 30 for the bump, but normal maps always need to be set to 100. And then we need to tell Max that what we're dealing with is a normal bump, not just a regular bump. So we use a normal bump node. Double click on this and put the texture right here, and in this case we can just hop over to the regular bitmap section, and there we are, low poly normals map. So it's assigned now and there we go. So it looks very similar in this area to the low poly cube. As it gets to the edge, there's some difference there, but we're paying for 6 polys here. Oh, this one's sitting on the same texture. So this one is a zillion polys, and this one only has a few polys, but sitting next to each other, pretty similar. So that is the awesome power of normal maps. And as you can see, it's really not that complicated when you're dealing with simple geometry to make them. So there's an issue you are likely to see with any cylindrical object that you try to bake, and I'd like to show it to you and then show you how to solve it. So just go ahead and zero out the position of this cylinder here, and hit 0 to bring up the render to texture menu. And in the projection mapping section, I will click pick and then grab the high poly cylinder here. And reset the cage and push it again, just to make sure it's nice and clean. Add a normals map. Set the resolution to 1024 and click render. So you can kind of see what's going on here already, but let me go ahead and plug the normal map in and show you exactly what's going to happen here. Hit Alt Q to isolate it, and I don't need the projection modifier anymore, so I'll go and delete that. Add a normal bump modifier, normal bump node, and select the normal map that I just generated, and assign it to the object. So you can see it sort of captured that detail, but there's this strange, from some angles, like from this angle, this looks fine, but this one looks terrible, and from this angle, this one looks pretty good, but this one looks terrible. So what caused that? Well, when I added the projection modifier, let me go ahead and just add one back in here. And I will just reset it and push it again. So as I'm pushing it, what's happening is it's looking kind of at an angle down at the surface. It's not looking straight on. So because it's looking down at an angle, it looks okay if I look at the object from the same angle. But this is obviously, it looks really incorrect. So the solution to this is actually pretty simple. I'm going to go ahead and delete this projection modifier and show you what the UVs look like on this object. This is the top and this is the bottom. And here we have the normal map. So it's a little bit low res, but you can see what's going on here. Here are those patterns. This is called scalloping. So the solution is to open this in Photoshop if you've laid your UVs out properly. So the idea is whatever the cylinder is, you just roll it out and you make sure that the horizontal lines are all horizontal and the vertical lines are all vertical, even if it's not the most efficient layout for what the cylinder is. You've got to have them set up like this in order to use the following trick. So I'm just going to open this in Photoshop and bring it over here. So the idea is you want to just pick the thinnest strip you can get, just a few pixels, and then using transform, drag it all the way out. So the reason it's important to keep your UVs horizontal and vertical is so that you can easily select one little piece and then drag it out in either direction. And when I save this, watch what happens in here. So there's still a little bit of, like, you can see the low poly, but I'd rather see the low poly than that scalloping. That's kind of the compromise that we make. It's never going to look perfect, but at least this way it doesn't have that weird curved error going on. So again, whenever you've got a cylindrical object, it's really, really important that you have your UVs laid out horizontally and vertically. So the next thing that I'd like to show you can be a real-time saver. Here I have a finished asset, and the UVs are done and the textures are done. and I'll just show you what this looks like. If somebody were to ask me to add a hat or a cape or something to this guy, it would be very difficult to find enough free space in the existing UV layout to get the texture resolution that I need. So the only option really is to move the UVs around and then try to line the texture up underneath the new UVs, and that can be very difficult and tedious. So using render to texture, we can speed that process up a lot. So what I have here is that same geometry, but with kind of a randomly reorganized UV layout. As you can see here. So what I'm going to do is move this guy back to the origin. So I have the new UVs selected, and I hit 0. And select the old UVs for the projection target. And just double check the cage. We'll reset it and push it a little bit. And in the output section, we need to add a diffuse map. So by default, I'm using the diffuse map, but if you have a specular map or a spec alpha or a transparency map in the alpha channel of the diffuse map, all of those need to be added into the diffuse slot of the material that I'm using. So that's just a regular old standard material. Specialty materials will not work. You've got to make sure that you're using a standard material here. So this is the regular texture, and it's just plugged directly into the diffuse map. So this is where you would plug your normal map and your spec map and everything. It all go into the diffuse color. So I will just render it. Oh, I'm going to set this to 1024. And this is the new UV layout. Let me just bring that over from Photoshop. So here's the new layout, and one thing that you may notice is it's really, really noisy. It's got all these little black spots on it. And the very simple solution to that is to add a push modifier, which slightly increases the size of the new geometry here. Just a little tiny bit. 0.001 should be fine. And I'm going to hit 0. Actually, the menu's already up over here, so I'll just render it again. And now you can see it's nice and clean. So I'll just make a new standard material here. And apply it. And then into the diffuse color slot, plug our new texture. And there you go. Brand new UVs and zero shuffling around in the messing with the textures. So major time saver. And here are the two maps. So these were the old UVs, and here are the new UVs with presumably plenty of room for that hat. So that about does it for this episode on the render to texture workflow in 3ds Max. I hope you found it to be informative. Thanks for watching, and stay tuned for more tutorials from 3dtotal.com.